Now we are going to discuss some sample problems regarding the frames and mechanics. This is the very first sample problem from your book, that is for sixth sample problem. Let's look at the problem. The frame supports 400 kilogram load, as you can see. So let me select the pen and let us select the color. It is an important thing. Okay, red is just fine. Now, as you can see, this frame is supporting a 400 kilogram as shown in this manner. Now neglect the weight of the members, assuming these members are weightless, and the force induced by the load, and compute the horizontal and vertical component of all forces acting on each member. So we have to compute the forces acting on each member, horizontal and vertical. The first thing is we have to first determine the external reactions acting on this frame. We have three different types of reactions, as you know. One at joint A, the other at the roller D. The third one is due to the weight, that is 400 kilograms times 9.8, or you can just round it off to 10, that is 4 newtons, 4 kilonewtons. Now, basically what we are going to do is develop a free body diagram without representing internal L members, as you can see right in this figure. Now we can say we have to determine the all the external forces. First thing is we are going to use the three basic equations. As you know, sum of forces along x is equal to 0, sum of forces along y axis is equal to 0, and sum of moment about any point about A or D respectively. So we are going to solve this thing. First, we are going to say sum of moment about A is equal to 0. Based on this, we have eliminated the possibilities of AX and AY. All we have is D. D is a reaction force, and then we have a 4.8, that is 400 kilogram force times the gravity G, that much weight, that is roughly 4 kilonewton force acting downwards right over the roller right here, and they are going to cause this moment is going to have a arm this way, and it's going to create a moment this way, while this moment will have an arm this long, and is going to cause the frame to rotate this way. And here we have the values: 5.5, 4, 9.8 minus 5 times, this is actually AD, 5 meters, that is 1.5 plus 0.5. This, as we have seen right here, from A to D is in fact 5 meters. So we have 5 times D dx, and we have found the value of D. This is the D external force acting on the frame. Then we know sum of forces along x equal to 0, sum of forces along y equal to 0. D is being balanced by AX, and AY is being balanced by this. And as a result, we have found the value of AX and AY. Now, once the external forces has been determined, now we are going to find and move towards the internal members of this force, or internal forces acting on the internal members. Now, in order to do so, first we are going to separate each and every member, and we are going to draw the force diagrams, action reaction diagrams of direction force vectors over the each member. Remember, if we have assumed a wrong direction, we are going to keep it and follow through the entire calculations. So the first thing is we have separated the roller right here. We know the tension D is acting downwards, and this is the rope going over this over the roller, and then the pin joint is going to face the same kind of reaction forces opposite to this force and opposite to this force. So the roller has been isolated. The same forces are going to act on this pin joint, which is going to act on the member, and the member is going to act opposite of these two reactions right here, and then this rim is going to have a corresponding reaction phenomena. We have developed EX, then we have developed, this is EX by 2. How do we get this EX by 2? Is from this triangle as shown in the figure. We have the value of, we have this height, we have this height, length, and from there we can measure the ratio of this thing, and we know that this is in fact the half of the actual EX. This means this is going to be half this length, and this will be the half of this entire base. From here we have developed the reaction forces of BY, corresponding BYs, bx corresponding bx, then the where this wire is connected to this rod AD, and then C connected to the rod AD. So we have uh, two basic elements where maximum forces can be found. The first basic element is B F, and the second member is AD. So we are going to focus, as we can see, the maximum number of forces are being resolved on these two members, and we can find the other value for forces on the other members easily by resolving these two members. So first we are going to focus on the element BF. This is point F right here. Now if you take this element, we are going to say the sum of moment about B is equal to 0. So how many forces are acting? Number one, if you take this element from point B to point F, draw a straight line, the only force that is going to create a moment is this EY, and this Fy right here, and we can write this equation right here. 3.92 is where, due to the weight of the rod, times 5 is the total length of the rod, half is the fraction coming from this triangle right here, Ex times 3 is the length of the moment arm, so we find the value of Ex. Similarly, if we say sum of forces along y-axis is equal to 0, so By times half of Ex, that is Ey, then f of y, we can solve this equation and we'll find the value of By. Similarly, if we solve for Ex, that is Bx, and then the tension or the roller reaction or along x-axis and the value of Ex, as we know, anything moving this way is considered positive, so negative Bx plus Ex minus the tension force, we can find the value of Bx. So from there we have find the value of the action reaction forces at point E. We have find the action reaction forces at point F. We have find the values of at point B. Now we can use this thing and introduce these values over the element, over the member AD. Now if you look at the AD, we have the information of a point A. We have the information of the point where the cable is connected to the rod AD. We have the value of B coming from the element BF, and we have the value of reaction joint D coming from the wall reaction. The only unknown variable, the only unknown is the point C along CX and CY. Now this can be solved easily by again taking sum of moment about point C equals to 0, the sum of forces along x-axis and sum of forces along y-axis is equal to 0. Solving this equation, we can see the first part equation, sum of moment about C is equal to 0, is in fact the check that the value calculated previously for B is very useful. As a result, it proves that we have come across the correct values. Similarly, if you solve for C f of x, and we can find out that if we put this value, we'll find that Cx and Cy is in fact similar to Ex and Ey. The same amount of force reaction is acting on it, and it is going to verify the same thing for f of y, and we get the same values. Now this is how you're solving this simple mechanics. But if we look at a certain advanced mechanics, it is going to be a little complicated. Now you have to understand, while solving this problem, we took advantage of element, external forces, internal forces by using two member forces, three member forces, and we have assumed the forces to be in equilibrium. You have to understand, in any machine design or any framework, sum of forces and sum of moment about any point has to be 0, as your entire structure is in equilibrium. Even if it is a machine, it will achieve an equilibrium for that particular instant for which you are going to solve your problem. Now let us look at another problem. This is the problem from your book again, 4-8. This is the 8th sample problem. Let us look at this problem. The machine shown is designed as an overload protection device which releases the load when it exceeds a predetermined value T. T is the force, tension force based on the load. A soft metal pin S is inserted in the hole right here, in a hole in the lower half, and is acted by the upper half. When the total force on the pin exceeds the strength, it will break. The two halves then rotate about point A under the action of tension, that is BD and BC, about this point. as shown in this sketch right here. Now the roller E and F release the I bolt. This is the roller E and F. They are going to release this bolt to determine the maximum value allowable tension T if S will share with the total force of 100 newtons. Also compute the corresponding value forces on the hinge pin A. So here's the problem in simple words. This is a protection unit. You have a pin S, you put a pin of soft material in S. This pin has a limiting value. When this I bolt, the tension T increases to the value greater than the shear value of this pin, the pin is going to break. As a result, the whole mechanism is going to rotate about joint A. It is going to rotate because there is a tension in element BD right here and CD, and they're going to pull the clamp apart. As a result, this eye bolt is going to roll across and fall down. So we are asked to find, number one, the value of T, number two, how much forces are acting on A. So here's the simple thing, simple mechanics. Assuming our structure that value, to find the value of T, it is being balanced by the force X component of this force right here and this force right here. So we know this angle, that is 120 by 10 theta by perpendicular over base. Find the value of theta here, right? And then this value here. From there we can find the corresponding solutions, corresponding values. So we can say B cos of theta plus C cos of theta minus T. Remember, B and C are equal in magnitude. As a result, we can find the value of B in terms of T. Now we have find this value of X. So let's move to the other part. We know sum of moment about A is equal to 0. That is true, and it can be calculated from here. Since the same amount of T is being passed right here, and this T, half of the T is acting on roller E and the other half is acting on roller F. It's a simple equilibrium problem, as you can see. So we have T half cos theta 2 times 50 coming from the moment right here. It is going to cause a rotation about point A, then another rotation about due to the this T is going to create a rotation from here to this point, and it's going to cause a rotation about A, while this T is going to cause rotation 36, that is 15 minus 24, and this T is going to cause rotation about here, T by 2. As a result, there is going to be another force coming due to the S causing the rotation from this length, and you have got this one moment from bigger end, from the A. This moment is generated from T right here, and this 36 times 800 is coming from S, and this 26 is coming from B times 26, and this thing is going to cause the system to rotate, and this all have to be equal to 0. This is only from one side. As a result, you put this value and you have find the value of B. You put the entire value right here in T, and you can find the value of T to be 1 point this or 1 point this kilonewtons. So how do you find the final equilibrium equation? You say sum of forces acting upwards should be equal and opposite to sum of forces acting downwards. So you got S minus B sine theta, this is this component, will give you the value of A, and you have found the value of A to be 492 newtons. This is a simple mechanics. You have to understand, we have isolated each member and we have isolated each member and we have created how the forces are traveling from each element to an element. As you know, roller provides only one reaction. It does not allow it does not allow moments. As a result, roller can be only a reaction phenomena, as you can see from point E and F. It is a weight phenomena, and they are only reacting to the weight of I bolt and T. The same amount of T is transferred from BD and CD to the main cable T, and then when S breaks, let's say for that particular instant, when S is about to break, we are going to solve for that particular instant. And when we solve for that instant, we can finally find out how each element is handling the force. Remember, before breakage, there is going to be a maximum amount of load acting on it, and that is the point where we will be solving our system, for will be that particular instant will be the time for which we will be solving our system. Once it has achieved the final state, it is going to have a minimum force acting on it. As a result, we will not be solving this problem. The solution comes from the limiting factors, not from the final factors. You can practice the end numericals for further practicing, and if you have any problem, feel free to contact me. I will help you out. I will in future upload certain numericals, certain more educational numericals, and will teach you how to solve further mechanics for this particular for these types of particular questions for your help.